Good afternoon, everyone, and welcome. My name is Gabe Arnold. I'm a technical director with the DLC. I have with me Levin Knock and Damon Bassetti, who are program managers in our controls team. And this is a webinar on our new version 2.0 network lighting controls requirements. I want to thank you all for joining us here today. I'm going to start the webinar by going over some logistics. So everybody here is on mute, and we are expecting a lot of people, so we're going to keep people on mute through the duration of the webinar, but we would encourage you to ask us questions, and you can do that through the question feature of the webinar interface. We will conclude the webinar by having a question and answer session where we will answer some of the questions that we've received live, and then we will provide written questions that we will post to our website for all the questions that we've received. So as we go through the presentation, please do write your questions into the question pane. If you have any technical issues, you can write those into either the question pane or the chat pane. Damon, Levin, or myself will be monitoring that as we go and trying to respond accordingly. This presentation, a version of the recorded webinar, will all be posted to the DLC website after the webinar is completed, probably sometime next week. Our agenda here today, we're going to begin by providing some background for these technical requirements for a qualified product list for controls and some of the objectives that we're trying to achieve with it. Really set the context for the requirements. From there, we'll move into a review of the new version 2.0 requirements. We'll then discuss the schedule of revisions, eligibility of systems, policies, the qualification process, review the application form, and then conclude with a question and answer session. So I will be starting the webinar here. I will then transfer to Damon Bassetti, and then Levin Knock will finish things up before the Q&A period. So first of all, why has DLC developed a qualified products list for network lighting controls? DLC's mission is to drive energy savings, and what we're looking to do with this QPL is work in partnership with the lighting industry and the utility programs to drive energy savings by accelerating the adoption of network lighting controls. We are looking to accelerate the use of this technology to accelerate the sales of this technology in the market. We are also looking to create a single point of entry and an efficient process for manufacturers to participate with efficiency programs on an at-scale basis. Prior to development of this QPL, manufacturers would have to qualify their systems on a project-by-project, utility-by-utility energy efficiency program basis. And so providing this one-stop shop provides a method for you to access this market and just qualifying your system one time. We are also looking to address a significant issue with this technology right now. There is a lot of confusion in the market. From designers, from specifiers, from some utility staff, from end users. It's a technology which is changing very quickly. It's relatively complicated. It's a very different technology than what it was many years ago. This technology, advanced network lighting controls, is more akin to IT technology than traditional lighting controls. And we believe that providing this QPL resource, it's a resource that people can use to better understand, identify, evaluate the control systems that are available to them to use on particular projects. More specifically, for energy efficiency programs, this QPL serves an important role as a resource to helping them scale up in support of this technology. Prior to this QPL, as I mentioned, utilities, energy efficiency programs would evaluate this technology on a project-by-project, sometimes utility by utility basis. And it was really, the utilities were really having to use a very customized approach with it. And anytime you have a high level of customization where you're having to evaluate things on an every project by project basis, it gets in the way of scale. And so what we can do with this QPL by setting broad scale requirements across, that work across North America, is we're providing a tool that enables utilities to not have to do all that customized evaluation of the system on every single project. Rather, they know the systems that are pre-qualified and eligible for their programs up front. They're on an easy-to-find and searchable list that's provided by DLC. And this is really a necessary thing to enable them to move away from some of the more customized project-by-project evaluation to something that's more scale-based and more repetitive. Secondly, we are working with our utility partners to develop new targeted program offerings, new targeted incentives and rebates for this technology. Those are the things that are actually going to play a big role in helping to drive increased adoption of this technology across the market. We really need these targeted promotions, these new rebates and incentives that are developed for this technology. And the QPL serves an important role in those types of targeted offerings because it provides a resource that utilities can provide to their customers, their vendor partners, contractors, specifiers, and designers about what systems are actually eligible for those new specialized or targeted rebates incentives that they're offering. So this is really a critical resource that's needed for utilities to increase and scale up their support of this technology. In addition to that, the utilities are looking to improve this technology over time, improve the performance of it, improve the reliability of it, improve certain aspects of it so that it aligns with some of the utility needs and desires. For example, the utilities are looking over time to start to leverage some of the energy data that's provided by these systems. And, you know, it's difficult for them working on an individual utility efficiency program by utility basis to communicate to manufacturers the changes or needs that they're looking for. And so by joining up around this national scale QPL that utilities across North America subscribe to, it provides a mechanism for them to communicate back to industry on a unified basis what their needs are for this technology moving forward, a mechanism to encourage manufacturers to improve the products. This QPL and technical requirements are part of a larger effort that DLC is implementing to accelerate the adoption of this technology. You can see in the upper right there, we have the Network Lighting Controls QPL that we're talking about here today. We've also been working on a suite of demonstration projects. The first one has been published to our website, and there will be more that will be posted to our website over the coming months. We've also been developing a training program, a training curriculum for designers and installers around this technology that really focuses on some of the technology innovations that are improving the performance of systems, that are reducing the cost and complexity, that are addressing some of the industry barriers that Damon, who will be speaking later, has been working on. And that's something that we will be we've run some pilots and we'll be deploying on a larger scale basis over the course of this year and into next year. We've been working on a savings calculation tool. This is intended really for utilities, but we will be considering making this tool available to a wider audience in the future. It's a tool which calculates savings for these advanced control systems. How much do you save when you layer all these different control strategies on top of one another? And how much do you save versus existing conditions, as well as versus energy code, a key need for utilities. So that's another piece. We've been working on a lighting control savings database. This is a project where we are collecting data on projects that have used advanced lighting controls, network lighting control systems. And we're going to be publishing a report later this year with the results of an analysis on that data. What we're looking to do with it is develop more reliable predictions, more accurate predictions for how much this technology can save on a particular space type, on a particular building type. This is another piece that's needed for the utilities to be able to develop specialized program offerings, new incentives, new rebates for this technology. When they develop these new programs and these new rebates, they really need to have strong certainty in how much the technology saves, and that's what we're intending to fulfill with this project. And we have a number of manufacturers we've been working with to collect some of this data that we'll be analyzing over the next few months. Lastly, working with our utility partners, and really they're the ones who are doing all the work here, but we have a number of them that are now starting to develop new rebate program offerings, targeted rebates and incentives specifically for this technology. We have a number of them that are now available and were presented at our Control Summit back in Atlanta in April. And you'll see more and more of these rebates and incentive offerings specifically for this technology and based on our QPL developed over the course of this year and into next year and into the future. All of this is intended to achieve the full-scale adoption of network lighting control technologies by addressing the barriers that are preventing the adoption, by equipping the efficiency programs with tools to enable them to scale up, and by serving as a mechanism for collaboration between industry and between the energy efficiency programs. We have a lot to improve on, and many of the webinars where we talk about our network lighting control efforts, we present different data points on this. And so here's one data point that comes from the Commercial Buildings Energy Consumption Survey that shows us the percent of buildings that have a particular control strategy in them. And you can see from this that only, for example, 2% of commercial buildings have daylight harvesting in them. Much less advanced lighting controls or systems that DLC is qualifying. We have run some analysis on this, and the penetration of these network systems in commercial buildings is probably somewhere in the 1% to 2% range. So a lot to improve on, and what we're hearing from a lot of people in the market is, while we're having tremendous success at attaining customer adoption of LED lighting, we're still very challenged with the adoption of network lighting controls, and that's what we're looking to change. This is just one other data point specifically from the Northwest, and one of the things we like to highlight here is again, daylight harvesting, which is showing up as photocell control. They actually did a survey of a lot of different buildings in the Northwest, 791, and they looked at what is the percent of lighting power controlled by a particular control strategy. And so you can see photocell controlled lighting, inside buildings, that's daylight harvesting, still registering at 0% of the lighting power installed in buildings in that area. And this is a pretty progressive part of the country in terms of their energy efficiency policies and practices. So again, a lot to improve on. So here, let's start talking about the new requirements. I'm going to start this by describing our revision process. This is the second major version of our specification, 2.0. We issued the first version back in, I believe it was April of 2016. And we are now on an annual revision process where we revise these requirements every year on June 1st. The reason for the frequency of revising the requirements is because the technology is changing so quickly. The standards are evolving and changing very quickly. And so are the manufacturer's offerings. And we really want to make sure that with these requirements and with our QPL, we are keeping pace with the technology, keeping pace with the evolution of standards, and that the information that's listed on our QPL about particular systems is current with the manufacturer's offerings. We recognize that this is a very frequent revision cycle, and because of that, we allow what is effectively a 1-year grace period. After your system has been listed for a particular version of the specification, at the time of the next revision in June, you will have the option to relist and keep your system fully qualified against the prior specification for a 1-year period. So this provides a 1-year period for a manufacturer to change their system if they need to in order to keep it listed. We begin this revision process every February to allow time for stakeholder input. So you can see the timeline of how this worked this year in 2017. We issued the first draft of version 2.0 on February 2nd. Comments were due on March 8th. We then held our control summit in Atlanta. This is something we do every year, where we bring stakeholders together, whether you're a manufacturer or a utility energy efficiency program or a distributor, to talk about what's been proposed, the comments that we've heard back from stakeholders, and decide a path forward around some of these topics. So based on that discussion we had at Control Summit on March 23rd, we then issued a second draft on April 12th. Comments were due on May 17th, and then we issued the final version of 2.0 on June 1st. And we expect this process will look very similar in 2018. So what were the key changes from version 1.0 to 2.0? One of the most significant changes is that we've now added exterior system requirements. Previously, the specification, the requirements in the QPL was only for interior network control systems. And so now we've got a category for exterior network controls, and we'll go over those requirements in a moment. We made probably hundreds of changes to refinement of language and standardization of acceptable responses for manufacturers. We've now got 18 systems that are listed on the qualified products list. These are all interior systems to date. In the first year of implementing these requirements and implementing the QPL, we didn't know what we didn't know. We didn't know what information the manufacturers might have for us in terms of meeting the requirements, what their responses would be, what some of the different characteristics would be with their systems, and how that would vary from manufacturer to manufacturer. So with the application process last year, we accepted free-form responses from manufacturers in providing information to us about their system as they were going through the qualification process. And now that we've gone through that with 18 different systems, we have a good sense of what the universe of responses are from manufacturers. And so we've made a big shift with this version 2.0 and the associated application to where there are standardized answers from manufacturers. An example of that is, what dimming standards does your system comply with? And there's actually a pick list to choose from instead of a free-form type response. And so Levin will be providing an overview of the application a little bit later, and he'll be talking about that further. But we think it's a big improvement to how we're collecting information from manufacturers and how they'll be listed on the qualified products list in a more comparable, a more consistent way. We've also added some new categories of reported system information. If you've looked at our QPL, we report a lot of different capabilities and whether systems have them and some characteristics of them. So we've added a new characteristic, which is whether a system includes an API and some of the characteristics of that API. This is, I guess, a relatively new method of connecting, exchanging data with other types of building systems with lighting. We've added a capability for color tuning. So we'll be reporting, allowing you to identify systems on the QPL that have color tuning capability and a dedicated interface for that. We've added a new characteristic of something we call startup and configuration party. So we're asking manufacturers to identify on their QPL who is most commonly responsible for starting up and configuring the system and how much training is required of that party. This is something that's been asked for by some of our stakeholders to help them with product selection process. Some systems are more complicated, but also offer a much wider feature set. That's very important on some projects, and might work well with a more sophisticated customer, but they might require a much higher level of training to start up and configure and commission that system. Whereas there's some systems out there that are really much simpler. They have a more basic feature set. They're designed for a less sophisticated customer, and they're designed for a contractor to be able to install with very little training. So we've added a reported element to the QPL about this, and then we've also added an element for manufacturers to report security information. So we'll provide a little bit more detail about exactly what we're reporting a little bit later in the presentation. But these are the key changes. There was tremendous discussion at our Control Summit around the topic of energy monitoring. And that is something that the DLC will be looking at potentially adding as a requirement for 2018. I wanted to go ahead and mention that here. We had proposed it in the first draft of version 2.0 and got a lot of feedback, a lot of discussion at Control Summit that the standards were not ready yet to support that. So we'll be doing what we can to support the continued development of those standards and looking to require that capability beginning in 2018. And that will probably, I can guarantee, will be part of our first draft that we issue in February. Next, I want to talk about the warranty requirement. This is actually not changed from last year. We require a 5-year warranty for all components of the system that are addressed by the specification. The reason for this, reliability of these systems and persistence of savings of these systems is very important to utilities, to energy efficiency programs. And while warranty is not directly related to reliability of these systems, it can be a proxy for it when we don't have a specific reliability standard for these components that we can refer to. And so the utilities have asked us to encourage a longer warranty on these systems. There's another aspect to this where the utilities DLC requirements currently require a 5-year warranty on Luminaires. And as we move toward a future where these control systems are increasingly integrated with the Luminaires, we'd like to see the control warranty aligned with the Luminaire warranty. We do allow manufacturers to qualify for this if they do not have a standard 5-year warranty, but a longer warranty can be purchased to achieve that 5 years. We will be bolstering how this is displayed on the QPL going forward. It will clearly identify that a longer warranty needs to be purchased in order to meet the requirements. We require systems to be commercially available, able to be purchased, and with the complete documentation and literature readily available. We and our utility partners do not want to be listing systems that are not yet commercially available, that have not yet been installed and tested in a customer facility. And so part of the verification process here is that we'll be verifying that you have complete and final documentation available. We'll be verifying that we're able to purchase the system, and we'll be verifying that the system has been installed and operated successfully in at least one actual field installation. We do that. Field installation verification can be either through a published case study, or in a lot of cases, what we've done is followed up with a customer reference that has installed the system. And so there's more information about this requirement on the application form. We require manufacturers to provide a system overview presentation to qualify their system. This is 1 to 2 hours. Provide us some information about the type of applications you're targeting with the system architecture, some of the key capabilities, how the system's installed, configured, and commissioned. This information helps DLC better understand the system as we work through the review process. So this is something that's scheduled after the application form is received. So let's talk about the requirements themselves. If you're not familiar with the structure of our requirements, they're based on a set of required capabilities and reported capabilities. Required capabilities are capabilities, features that your system must have to be listed on the qualified products list. Reported capabilities are features, capabilities that you don't need to have, but the QPL will identify whether or not your system has them. So let's take a look at what these look like. This is the list for interior systems, and so it differs for exterior. So for interior systems, your system must be networked, and we'll talk about the definition of that in a moment. You must have 3 core control strategies: occupancy sensing, daylight harvesting, and high-end trim. You have to have a capability we call zoning. It's really programmable zoning, the ability to program your zones using software-based means. You need to have the capability for individual luminaire and device addressability, and your system must have continuous dimming capability. Then in addition to that, on the QPL, we identify whether your system has a capability we refer to as control persistence. We'll define this in a moment. Whether your system has scheduling capability, energy monitoring, device monitoring, and that's the wrong word there, it should say remote diagnostics. The type of user interface your system uses, whether that's an app or a computer-based interface, maybe a remote control, and the platform it's on. Whether your system has something called luminaire level lighting control. We'll talk about what that is in a moment. Personal control, load shedding, plug load control, whether you can integrate with other building systems or other external systems, and how. The type of emergency lighting system that your system can interface with. An optional reported characteristic for security, whether your system has the capability to provide color changing or tuning through a dedicated interface, and then also startup and configuration party, which I spoke about a moment ago. So this is on the interior side. And what happens on the exterior side is some of these capabilities for interior don't actually apply, and we've done some shifting things around. So on the exterior side, again, we require systems to be networked. For control strategies, we require either occupancy sensing for people or traffic sensing for vehicles. We'll talk about what those mean. We require high-end trim like we do with interior, but there's a change here where we require scheduling on exterior, something we don't require with interior. It's a more important and common control strategy with exterior. Photocell control, analogous to daylight harvesting. Again, this programmable zoning is required. The individual luminaire and device addressability is required, and the continuous dimming is required. On exterior, there are fewer of these capabilities that we'll be reporting or that apply. So control persistence again, energy monitoring, the device monitoring and remote diagnostics, the type of user interface, load shedding, external system integration, emergency lighting, security, color changing or tuning, and startup and configuration party. So we'd like to walk through each of these capabilities to provide you more information on the definition. This will be fairly high level, and I'd encourage you, if you have a specific question, about a particular definition or capability, to please write that into the question pane as we go. So the first one, and we require this both for interior and exterior systems, is this networking of Luminaire and devices capability. This does not mean your system must be able to connect to the internet. A lot of times when people think of a network system, this is what they think of, but that's not what we mean here. What we're talking about here is networking between the Luminaires and between the control devices, so that they're able to exchange digital data with other Luminaires and devices on the system. This is a core requirement that really enables advanced controls. The ability to layer multiple strategies over one another. In order to do that effectively, do it in a way that delivers occupant satisfaction, it's really essential that you've got this level of networking so you can exchange data between the different devices, understand how each one is operating, and implement a control strategy that's going to provide occupant satisfaction, provide flexibility to make changes over time to deliver that satisfaction. So in addition to requiring your system to have this capability, if you've looked at our QPL, if you've looked at our application, and we also ask you to provide us information, and we list on the QPL what are the size limitations of your network in terms of number of devices or number of nodes. Is this a small system designed just for a room or a building? Is this an enterprise solution? What's the maximum number of nodes you can work with? Also, what are some of the distance limitations? How far apart can the nodes be, whether you're talking wired or a wireless system? We ask you to identify whether your system is wired or wireless. Some of the networking or communication standards or protocols your system complies with, or is it proprietary? And whether your system requires a computer server. Maybe it's local computer server or cloud-based. And some of this information ends up on the QPL because these are important aspects for a user or a designer, a specifier, or a contractor to consider as they're choosing a system for a particular project. Maybe you're doing a building retrofit, you can't run new wires, and so you want to find systems that are wireless. Maybe you have a customer that really doesn't have much for IT resources, and therefore a system that required a computer server-based system probably wouldn't be appropriate for them. So you want to filter for or find systems that don't require that level of IT resources. And so that's what we're trying to do with this information. Next capability, occupancy sensing. I'll assume that everybody out there knows what this is. So this is something that we require for interior. On exterior, your system can either provide this and something we call traffic sensing. In addition to identifying that your system has this capability, we ask you to provide us the modes of detection if you've got, so the modes of detection, and then the coverage options if you have PIR type sensing. We also ask for information about the time delay and some additional information about the capabilities of your occupancy sensing. For example, can you set the system to a dim level when there's an unoccupied state? The next one is traffic sensing, and so this is a new one we have added this year. It is not applicable for interior, but as I mentioned, it's something we'll accept as an alternative to occupancy sensing. And so occupancy sensing is really about sensing for people. This is about sensing for traffic. And we will allow manufacturers to satisfy this requirement through one of our other capabilities, external systems integration, as long as it's documented in your literature that your system provides this capability. So just like with occupancy sensing, we ask you to report to us what the modes of detection are. If you offer this capability, maybe it's video for this one. think there's a lot of different evolving methods for doing this, even collecting traffic data from some of the mapping software companies and so forth. The next one is daylight harvesting and photocell control. So this is required for interior, required for exterior. The definition is really the same. Whether you're talking about daylight harvesting or photocell control, they're both control strategies that are automatically controlling the operation of lighting based on the amount of daylight or ambient light conditions. In addition to identifying whether or not your system has this capability, we ask you to tell us whether it's open or closed loop. Can it turn the luminaire fully off? What are some of the adjustment options you have with the system? For interior systems, can you integrate with automatic shading control? And for exterior, is your system able to, does it provide components to interface with an ANSI C136.41 socket? So this is the new NEMA standard socket, 5 or 7 pin that fits into the photocell receptacle of a luminaire and allows you to incorporate dimming and some other advanced control features. Next one is high-end trim. So this is the capability to set the maximum light output, to really tune the lighting to the desired light level at the time of installation or commissioning. You are basically setting a new ceiling light level for the system at the time of installation or commissioning. And then for the ongoing operation into the future, you might give occupants the ability to dim below that, but the high-end trim is set the new ceiling. This is going to be a strategy you'll be seeing a lot more of, and the utilities and energy efficiency programs will be encouraging a lot more of over time. It's something that's really enabled by LED technology, given that it's so dimmable. I think it's an opportunity we see a lot more of as well, because LED lighting is such better quality light. And so what we'd like to start seeing as standard practice, and I think you'll start to see this in utility program requirements, is as part of that installation of that new lighting control system, part of the startup and commissioning is to tune that light level to either meet IES recommendations, maybe you're going for 30-foot candles in an office, or to whatever the desired light levels of the occupants are. Sometimes that's not an exact science, and the facility manager might adjust this until they get just the right light level for what people are looking for. Studies are starting to show that this particular control strategy can save more than occupancy sensing, save more than daylight harvesting. It's a very big energy savings opportunity. There's a lot of different terminology that's used for this capability. We are calling it high-end trim, and we are referencing with that definition a NEMA standards document, LSD 64-2014. One of the things that we found as we were qualifying 18 different systems over the past year is that some manufacturers are calling this capability task tuning or tuning. We also had a manufacturer that was providing lumen maintenance dimming and calling it high-end trim. So just be aware that's an issue out there. If you go by the NEMA standards document for lighting controls technology, what we're talking about here is high-end trim. And task tuning is actually tuning the lights after the high-end trim has been set. It's the ongoing operation. Maybe that's just provided by a dimmer. We also ask manufacturers to report the range of high-end trim settings and what some of the default settings are. Next capability is zoning. You can think of this as programmable zoning, and what it is the capability to be able to group your luminaires and form lighting control zones for a control strategy by software-defined means. So actually programming what the groups are, what the zones are, and not doing that by which luminaires are connected to a particular 0 to 10 volt branch, or which ones are connected together on a power circuit. The reason for this is, the utilities, we're really looking for more reliable systems that persist over time, that the energy savings persist. And by being able to program and change your zones over time, what that means is, if something happens in the space and you need to reconfigure things, or maybe it wasn't commissioned, wasn't installed properly to begin with, we want you to be able to make changes to that system, reconfigure the zones if you need to, take a fixture off a zone without having to call in an electrician and rewire the system. Often what happens when the system has to be rewired is that the system gets disabled, and that's what the utilities have seen a lot of over time of these more advanced systems. So that's really what's driving this particular requirement. On the interior side, we require the capability to program your control zones for occupancy sensing, for high-end trim, and for daylight harvesting. There's an exception if you have a system that's built upon having sensors within every luminaire. That's a core architecture of luminaire level lighting control systems that we'll be talking about at a moment. And for these systems, the zoning is only required for occupancy sensing and high-end trim. You don't need to be able to form control zones for daylight harvesting if you've got a daylight harvesting sensor in every luminaire and it's automatically adjusting the light levels to the specific task. Okay, next one, I think I've got two more, and I'll hand things off to Damon. So luminaire and device addressability. This, in some respects, goes along with the zoning that we just described. And it's the ability to uniquely identify and address each individual luminaire sensor controller user interface device, allowing you to configure and reconfigure those devices and control zones independent of electrical circuiting. So it goes hand in hand with the zoning. There's been a point of confusion historically about this. There are a number of manufacturers that offer individual luminaire controllers that meet this requirement, and that's absolutely something, that's what we're driving for. We require your system to provide that capability. I think over time you will see utilities starting to require more and more of that, and it appears that the industry is moving in that direction. For many different benefits that it can offer. But I think we've got some hurdles to overcome before that becomes standard practice in terms of costs and perceived costs, as well as just changing the practices of how people do things out in the market, how installers install lighting. They're used to defining these zones by connecting them together in a zone of 0 to 10 volt wiring or a zone of line voltage wiring. And so there's some hurdles we've got to overcome there. But I think that's the direction the market will be moving in and the utilities will be encouraging. So the point of confusion is that, so we have a number of manufacturers that are offering these individual fixture controllers that are also offering a traditional zone-based controllers that is made to control a group or zone of luminaires, where you would actually define the groups or zones of luminaires by the 0 to 10 volt wiring. Systems that offer both those individual luminaire controllers as well as those zone-based controllers are acceptable. And I think there's absolutely some use cases where you want to be able to offer that zone-based capability. So that's something I wanted to mention here. The important thing is that you do offer that individual luminaire addressability capability. You do offer those individual luminaire controllers. If you also offer a zone-based controller, that's acceptable. Next is continuous dimming. So this is a core capability that we require all systems to have. We've defined it as you have to have a resolution of 100 or more steps. So in addition to identifying that your system has this capability, we ask you to provide us information on the different types of dimming that you support, the standards or protocols that you comply with, and dimming curves that your system uses. All right, so I will shift this over to Damon, who will cover the rest of the technical requirements.
Thanks, Gabe.
And you should have control there.
I think you also gave me, hold on, I need to get my screen ready.
Oh, I see. Hold on a second. Damon, I do think I want to stick to the master slide deck here. So,
okay.
Okay, you should be set.
Okay, cool. Thank you very much. All right, thanks, Gabe. I will bring us on home through the rest of the TRT topics. So this ninth one is control persistence. And in our first draft of the revised specification, we call this distributed intelligence. And we got some good feedback from industry members to name it after the end, the intended end for what we're going for, versus the means by which we hope to achieve the end. And so this is a reported characteristic for both interior and exterior. It's not required for anything. And it's also in the unique position of also being a child attribute of the Luminaire level lighting control as well. So, which in itself is reported and optional, but a requirement of labeling a system with the LLC capability will be to meet these requirements of control persistence. What we're going for here, kind of like Gabe was talking about before, is making sure that 2, 3, 4 years down the line, if there's ever any kind of glitch or issue with the system, that some level of control behavior continues to happen. And so if you have the thing that is being controlled and is furthest away from the main controller, if it loses that link, will it keep doing some kind of occupancy sensing, daylight harvesting, and high-end trim? And a really important phrase here is at the room level or finer resolution. If it's Luminaire level lighting control, then obviously it's going to be finer than that. But there is probably, there is definitely an entire class of products out there in which, even though a room might be cut off from a higher networked element, the remote sensors, controllers, switches, and luminaires might still be wirelessly meshing with each other and operating just fine. And so we didn't want to preclude that from being able to claim this measure of control persistence, because for for all intents and purposes, if they lose that link, they'll still be able to do some of those big three strategies and measures. We also give reporters on this topic the ability, or if they do more than these three on the application, on the QPL, we will be able to display anything additional that they also do. The next one is scheduling. It's, as Gabe was saying before, reviewing the tables, it's reported for interior and required for exterior. We kept the definition just about the same because scheduling is such an inherent aspect of exterior lighting controls. We feel comfortable requiring it for exterior products versus for interior, where scheduling and occupancy somewhat overlap with each other, are different means to achieve the same end. A key thing here is that astronomical scheduling is important for exterior systems, but we also need to see the ability that a user will be able to have some kind of special event provisions. So sunrise sunset programming is great, but if there's a festival going on the streets in the evening, or a sporting event or something like that, users will need to be able to have some kind of augmented way of scheduling behavior changes for the system. And there's also a couple of additional metadata that will be reported on the QPL, as you can see. That's how the control is implemented, whether it layers with other control strategies, and what are the means, or if it can be overridden by manual purposes or manual acts. Next is energy monitoring. Again, reported for everything, not required. The loud and clear message that we got when going through the specification review process on this was that everybody agrees on the importance of this for our advanced network lighting control systems. But in the absence of an agreed upon specification for accuracy, precision, interval length, things like that, it would be too difficult to compare apples to apples. So we're still making it available because people, our utility customers, or the people going through the system's selection and specification want to know these details about it, but until we can actually have some kind of standardization, we don't feel comfortable requiring it. So we're going to ask applicants to tell us and report, how is it metered? Is it a lookup table? Is it actually measuring direct current and voltage somewhere? Where is it being metered? At the circuit level of all of the downstream components, or at every single point of use? What's the accuracy? What's the sampling frequency? Is it seconds? Is it hours? Another thing is we're asking people to describe if there are clauses in their contracts with customers about data access. One of the increasingly important things is with energy data, energy monitoring, is that utilities wish to be able to use this data to augment or perhaps even replace their measurement and verification work and effort, because right now it's a very manual, duplicative process that they cannot apply very widely. And it would be fantastic if somebody is going through their utility program and picking and choosing which systems they want to incentivize in their service area, and then they'll be able to look for systems that make gathering that data easy and simple for them, because that is a new, but we expect to be rapidly increasing use case. For device monitoring and remote diagnostics, this is pretty freeform or wide open in terms of reporting it, because this is such a widely varying field. But it's reported for both interior and exterior, and we're asking applicants to report on the application what is being monitored at this, throughout the system, and also how that monitored information is being displayed or communicated to end users. Is it an LED on the fixture or a controller that is blinking in a certain pattern? Are there text message alerts that are sent to users? Are there notifications in the user interface? Just again, descriptive information about what is monitored and remotely diagnosed and what is being communicated to the end users. Similarly, we're asking for information with the type of user interface. This has not really changed too much from last year, but just descriptions of how users use it. What does the interface look like? Is there the ability to upload and display a floor plan? That spatial information is important to people, and they like to know if it's there, and because that makes a lot of other things easier for them from a commissioning and operations perspective. Another key question that we'll be asking the application is it read versus read-write? Can users of the interface consume information about how the system is operating, and that is the limit of it, or can they consume information and make a decision about how they want the system to change its behavior, and then send that decision back on out to all of the Luminaires and controlled devices? This next one is Luminaire level lighting control. Again, reported for both interior and exterior. But we define this as the ability to have a networked aux sensor and ambient light sensor installed into every single luminaire at the factory. So this essentially arrives at the job site with everything already integrated into the luminaire. There are utilities right now who are running programs specifically aimed at systems that support this luminaire level lighting control, or LLC, because in their experience this leads to faster installations, more persistent control savings, and higher levels of user acceptance from those very, very detailed and granular controls. The key points to remember about this is that luminaires, in order to claim this on the control specification, manufacturers will need to point to a product that is currently listed on the SSL QPL that does come available or is available to order with this integrated control. It could be the same manufacturers, it could be somebody else with a private label agreement. Either way is perfectly suitable to us, and we understand that sometimes you might have contracts that dictate what you can and cannot say about what is being private labeled or integrated, and so if need be, it can be private and not publicly displayed on the QPL. It'll just simply be answered not public at applicant's request. The other big thing is that, like I said before when I was talking about control persistence, LLC systems must have control persistence already in there. Because they have the aux sensor and the ambient light sensor installed in every luminaire, that essentially comes along with the ride. Personal control. This is what it sounds like. It's only an interior characteristic because we could not think of a way that this made sense to have on the exterior list. Although if we're presented with evidence otherwise, we're happy to consider that for our next round of specification review. But this is just a way for individual users to adjust how the lights are operating in a specific area. And the way that they adjust it is important. It has to be by a controller or a user interface that is networked. It can't be a hardwired switch with a 0 to 10 dimming outlet that only goes straight to the switch. And it cannot be available to via systematic access means. In other words, a user cannot be presented with a single whole building or whole facility top-down floor plan and simply trusted to just only adjust the lights in their own area without any kind of provision made to lock them out of areas for which they don't have authorization to change the lights. So the control interface has to be designed for a single user that does not give them the power to turn everything off or on. This can be done via wall switches that are networked boxes. They could be done via user interfaces or anything else. You just have to be able to show the documentation that meets the intent that we're describing here. This next topic is demand response, sometimes called load shedding. Again, it's a reported attribute for both interior and exterior. We ask you to clearly specify how this is implemented and specifically how the system receives its demand response trigger signal, if it's automated or if it's manual, and if the system supports OpenADR, which is a global open standard for doing automatic demand response. For plug load control, this is, I apologize, I believe I made a mistake on this slide. I'm pretty sure it's not required for interior or exterior. It's reported. I'll double check on that, and my apologies again. This is the ability to with data collected by the lighting system, either scheduling or occupancy, can you control power being delivered to plug load receptacles? We are pretty open-minded about how this happens. We just ask for documentation and show us the control strategies and how they're mapped to controlling the plug load. We also ask you to show us if it's the outlet level, individual plugs, or the circuit level, or something in between. External systems integration is a pretty broad brush. But what we intend is to aid users in understanding what other systems they can connect up to the lighting control system. And these could be things as like the building or energy management systems, HVAC systems, or even speaking to other lighting controller systems that might be coexisting in the same building. And we are agnostic in terms of the means by which it connects. We just ask that you tell us those means so we can make it available to users of the QPL who are looking for, example, something that is BACnet compatible, because they know that they've already done a lot of work to build BACnet into the rest of their building, and that's a desired attribute that they want. Or if there's an API, application program interface, they might have software staff who are highly capable of adapting, again, existing systems with current API documentation provided by new systems vendors. If you are going to claim this capability, which is again reported, we ask that you show documentation for how it works. So something as simple as, we do BACnet would not be sufficient. We'd like to see some kind of a certification document or other kind of guide for how to implement BACnet links between your lighting system and this external systems integration, along with which data types are actually shared. There's a wide range, even within a certain protocol, for what exactly you're sharing, and that would be important information for users to understand. For emergency lighting, it's extremely important for us to note that we do not intend for this to be an assertion of complete compliance with any kind of emergency lighting or life safety code. Kind of like what I was just saying with the external systems integration, understanding how the lighting control system can or cannot coexist with other systems, including emergency lighting, is an important system selection step in the system selection process. So what we intend to, and with this, is to give manufacturers a place to post a source of information for system designers who are looking for information about the emergency lighting capabilities. So this would give them a single point to jump off into each manufacturer's specific code compliance documentation, so they don't have to run around and hunt for it all over the internet instead. So just with that caveat strongly into place, that's what we're intending to do with this. In our worldview, we view this as being one of 3 emergency power sources, either on Luminaire energy backup, a remote source that is switched at the Luminaire between 2 parallel sets of wires, or a remote source that's switched to a central location with only 1 set of wires heading to the Luminaire. So this is a source, this is an opportunity to place a sign in the road for system designers who are specifically looking for information about your system's emergency lighting interoperability and provisions. Nothing more. And we look forward to watching how this is used throughout the rest of the program year and getting user feedback on how useful it is. Similarly, for security, there is a lot more awareness of security issues and topics than there is standardization of security. So we don't want to make assertions that are not backed up by our own technical experience, but we also want to encourage sharing of information about security details. So manufacturers of systems, we're providing you a place on the QPL to simply just post a link to any information that you would like potential users to understand about your approach to security. It could be as detailed or as non-detailed as you like, or you don't even need to put anything down there if you wish at all. But it's simply a place to put information to participate in the conversation around security. For color changing and tuning, this is a hot topic, and so we came up with this definition. And this is simply the ability of a control system to shift the output or color of the Luminaire via a control interface. And so this needs to have at least 2 settings in the interface. It could be buttons, it could be software, it could be LEDs, but there needs to be a means for users to shift the color temp of the Luminaires controlled by the system. We also would like to see installation and configuration documents that show to users exactly how to work this as well. Finally, this is the startup and configuration party. Like Gabe was talking about before, we're trying to help users understand the work required to configure a typical installation of a facility. And we completely understand that typical installation of a facility can be a relatively coarse definition, and there's going to be some inherent judgment calls in this. We're essentially taking them on face value. If you think about making this more specific, like dollars per luminaire in commissioning costs, those get much harder to precisely nail down, and I would argue not add as much value to the users of the systems. We are aiming at simply an indicator of relative speed and complexity to install a system to the extent that all of its required capabilities are functioning. So for example, if there was a system that took 1 day to configure and install all of the DLC required properties, addressability, occupancy sensing, task tuning, continuous dimming, all of our attributes, but it also had a backnet integration, we would not consider the work required to make the backnet integration as part of this typical startup and configuration costs, because that is one of the reported attributes, not one of the required capabilities. And specifically, anyone who's done one of those external system integrations can probably raise their hand and attest to sometimes those steps can take longer than you'd like because you're coordinating multiple parties, maybe third-party vendors. And so we don't want to muddy the waters of the core meaning of what it takes to start up and configure one of these systems. Okay, Gabe, I think that's it for me. Thank you, everybody, for your attention, and I'll hand it back over to our Levin.
Okay, Levin, you should have control there.
I should have control. Stop showing screen. Okay, I'm not seeing how to change the slides. Oh, there we are. That's how we change the slides. Thank you. So now we'll take a look at the new application. It's online at the DLC website. When you select lighting controls, then qualify a system, then application instructions, and then scroll to the bottom of the page. We've made many of the questions multiple choice this year, and we hope this will make your job easier than last year with clear questions and a choice of answers. Here. There. Oops. Sorry, still getting the hang of this changing slides. We're moving towards an online application process. The application form this year is an interim step in that direction. It is still an Excel spreadsheet for now. 2 versions of the application are available. One has macros to expand and collapse each section. The other one has no macros for anyone who works in a macro-free environment. This slide shows the rolled-up view of the macro version, showing the 22 capabilities from the technical requirement, plus number 23, an overview of the manufacturer and system. Column K, over here, has a space for each reference with a file number and a page number, and I'll tell more about that a bit later. There's one application form, whether your system is for interior or exterior. Some questions apply to both applications, and other questions only apply to one application or the other. Columns B, C, D, and E show this distinction. Any capability that's required, such as occupancy sensing, would be marked in red in a capital letter with an I here in B for interior and in column D an E for exterior. Other questions that are not required are down here marked with a little letter, a little I or a little E. In the macro version, you can expand each section by clicking the plus sign here at the left-hand side of a row, or you can expand all the sections by clicking this one up at the top left corner. In this slide, section number 5 for high-end trim is expanded. There's a section title at the top of the section in row 134, and then a duplicate header down at the bottom of that section in row 143. You can collapse an expanded section by clicking the minus sign at the bottom of the section, or by clicking this bracket anywhere along this section. And then you can also collapse all of the sections by selecting this 2 up in the top left corner. In the application version without macros, all of the rows are always displayed. The 1 and the 2 up here in the top left corner are disabled. Both of these forms are now available on the DLC website with or without macros, and you are welcome to use either one that you prefer. As I mentioned before, many of the questions are multiple choice. Click a box, one of these boxes in column H, to put a check mark in any of the rows that apply to your product and leave the other rows blank. When you enter an answer in column H here, then the same row over in column K becomes highlighted. You can see I clicked here, and then this became highlighted in column K. And that shows that a reference is needed in that row. So each reference is a file number with a page number and possibly also a section number. This snapshot of a Windows Explorer web file folder shows an example of reference documents for a product. As you collect references to submit with an application, rename them by adding a 2-digit number to the beginning of each file name as shown here. This takes a little extra work up front, but then it makes the whole process go more smoothly because it's easy for you and for the reviewers to refer to each document quickly. The names can be in any order you choose. For instance, the user guide does not have to be number 1. Here's an example of how this looks in an application. Rows 225 and 229 are completed with a check mark and a reference. The other rows are blank because they do not apply to this product. So you can see this is file number 1, page 27. Now we'll take a look at the qualification process and fees. For systems that are currently listed on the QPL, June 30th is a deadline to submit a new application with supporting references. If a new application is not received by June 30th, the qualified system will be removed from the QPL until a complete new application and qualification fee are received. If a new application is received by June 30th, then the qualified system will remain on the QPL through the duration of the review process until the application is accepted or rejected for qualification. As part of the review process, an invoice for the qualification fee will be issued. If payment is not received within the payment terms of the invoice, which is 30 days, then the system will be removed from the QPL until the payment has been received. A system will be listed on the Network Lighting Controls QPL according to the name that the system is marketed under. If one name covers various system configurations, that single name will be treated as a single system. Some systems are marketed with private labels, with multiple marketing names for identical systems. In that case, the fee for the first application is a standard full price. After that, additional names can be qualified using basically the same application with a different name for a reduced fee of $5,000 per name. Whether you qualify an interior system or an exterior system the fee is the same. If you want to qualify both interior and exterior under a single marketing name, then the fee increases by about 50%. If your system is not already qualified on the QPL and it's new to DLC, so you're not worried about keeping it active with the June 30th deadline, then you can submit a new system application at any time. The qualification will last through June of 2018, when it will need to be renewed. And therefore, the application fee is prorated throughout the year, as shown on this chart, based on the time remaining until the qualification expires in June of 2018. And this chart is copied off the website, so you can find that there under how to qualify your system. And now we are back to Gabe for questions and answers.
All right, thanks, Levin. If you could, I'll let you advance the slide a little bit later. So we wanted to spend a few moments here answering some of the questions that we've received thus far. Looks like we got a handful, not a tremendous amount. So there was one question about the lighting control savings database project we talked about at the beginning, asking whether we would attempt to quantify potential savings from non-energy savings, e.g. asset tracking, some of those new capabilities and benefits that lighting systems are providing that go beyond energy and lighting. And the answer to that is no, but that's absolutely something that we and other people are looking at, and we know it's a need out there. We have another question, which is, what exactly are 100+ steps? So this is referring to the continuous dimming capability. And what that is the resolution of the dimming control signal. For instance, Dolly provides 100 discrete digital steps. And so that's close enough for us to consider it continuous. There was not any industry standard or consensus around what exactly continuous dimming means, and being able to change the light level of something on a continuous level so that the changes are imperceptible between the steps. And so we defined it as your continuous dimming needs to provide at least 100 steps of resolution in your dimming signal. Next question is, what does it mean by required at interior or exterior system capabilities? Are we saying that all single or family product applications should have some sort of lighting controls? Okay, so I think there's some confusion here. In that the question is about single or family product applications for luminaires or lamps. And those requirements and the application process and the qualified products list for lamps and luminaires is an entirely separate process from what we're talking about here today. The DLC maintains both a luminaire and lamp qualified products list, and there's a set of requirements for that. And then we also have separately a network lighting control system qualified products list, and there's separate requirements from that. So they're entirely separate from that. And so if you have a lamp or luminaire product or family, none of what we've talked about here today applies to that. You should continue to qualify that product through our solid-state lighting qualification process and meet the solid-state lighting requirements. That's not to say that someday in the future we're not thinking about how we might integrate these lists and potentially have some requirements for controls on luminaires and lamps, but we're not there yet, and that's some date into the future. There's a question here, since color tuning luminaires are not currently allowed on the Luminaire QPL, will you provide the opportunity for compatible luminaires to be highlighted? The person asking the question is correct in that DLC has not yet finalized a policy or method on the luminaire and lamp side for qualifying luminaires or lamps with color tuning capabilities. And that's something we're working on. We'll hopefully have a policy in place by early next year that allows that qualification to happen. In the meantime, the answer is no. We don't have a mechanism to identify compatible luminaires with control systems that have this color tuning capability. That's absolutely something we are thinking about doing in the future, but not ready yet. So there's one last question here. Make sure I understand it. It says, must existing systems on the list provide updated data relative to the new requirements before they can remain on the list post-June 30th? So the answer to that is yes. You need to resubmit a new application using the new application form to remain qualified, and that must be received by June 30th in order to remain listed. I think that's it. I'll give maybe one more second if anyone wants to add another question. All right. Well, I hope that those responses answered all the questions. If they didn't, you can always reach us.
Gabe, we got one more.
Yeah. Okay.
What type of documentation is sufficient for the question that asks about the startup and configuration party? Levin?
Yes, this question is unique in that no documentation is required. We are simply asking for the opinion of the applicant. All the other questions, we need a reference document, but this one we were trying to imagine what a reference would look like, and we think we're just asking your opinion on that one.
Thanks, Levin.
It looks like we got one other question as well. This is related to the earlier question we received about what to do with a lamp or luminaire application. And so they're saying the QPL under the DLC website, is this the same website that shows the list that will receive the rebate? On the DLC website, we have two QPLs, two sections of our website. There's a QPL for lamps and luminaires, solid state lighting QPL, and then there's a QPL for network lighting control systems. So these are two separate lists, and you'll find that utilities, energy efficiency programs, are offering rebates for lamps and luminaires, and they reference the lamp and luminaire SSL list. And a growing number of utilities are offering rebates, incentives for network lighting control systems separately, and they reference the network lighting control list. Hopefully that's clear.
I will mention that.
Go ahead.
Oh, if people are following the questions and answered, I put an answer in the wrong to the wrong question, so I apologize about that.
I don't believe people can see them, so so that's okay. Looks like we got one last question, which is there typical security documentation that can be provided for a system that interfaces with an IT infrastructure?
I think that, and please feel free to jump in on Gabe or Levin, but I think that's part of why we're providing a free-form space for manufacturers to put information of their choice on that they would like to share about their security, their thoughts on security as it applies to their systems. There is not a lot of standardization on that right now, especially for IoT and lighting-specific topics. And so can you go off and search the internet for white papers on security approaches? Yes. Are there things that are broadly universally decided to be applicable towards specific lighting control systems? Not necessarily. So the system architects and engineers who are working on your systems might be the best ones to talk to about what they think might be a useful high-level thing that you would want to share with customers. And if there is something like that that you can determine, we're happy to post on the QPL. So users of the QPL will be as informed as you'd like them to be on this important issue.
Thanks, Damon. Levin, can you advance the slide? I'm not able to do it for some reason. There we go. Okay, well, that brings us to the conclusion of the webinar. If you have any additional questions or comments, you can see our general info email address on the slide there, and we really do monitor that every day and respond to it, so please don't hesitate to email us. We really thank you for your participation with us, listening with us here today, and hope you enjoy the rest of your day. Thank you.